Welcome to SureSolv. This is Atanu Chaudhary. In this session, to solve both the chosen problems in mind, we'll have to use the sum of inverses property in various ways, along with speed techniques and special forms of pattern identification. The first problem. The first problem is, if a greater than 1 and a plus 1 by a equal to 2 1 by 12, then the value of a to the power 4 minus 1 by a to the power 4 is option A 57895 divided by 20736, option B 57985 divided by 20736, option C 59825 divided by 20736, and option D 58975 divided by 20736. These are large values. To solve the problem, we have to transform a plus 1 by a to a to the power 4 minus 1 by a to the power 4. That's obvious, but a large amount of calculations may be involved. To cut short the calculations, we'll use speed techniques. First, we break up a to the power 4 minus 1 by a to the power 4 into its three factors. A square plus 1 by a square multiplied by a plus 1 by a multiplied by a minus 1 by a. We know the value of a plus 1 by a equal to 25 by 12. Getting the value of a minus 1 by a would involve less calculations in comparison to getting the value of a square plus 1 by a square. A minus a whole square will be equal to a plus 1 by a whole square minus 4. The value will be then 25 square by 12 square minus 4, which is 625 by 144 minus 4. Now 4 times 144 is 24 square. We took two numbers of factors of 2 from 4 and combined them with two numbers of factors of 12 in 144 to get 24 square. 24 square we know to be 576. So the numerator will be 625 minus 576. The result 49. So a minus 1 by a whole square will be 49 by 144, which is 7 square by 12 square. A minus 1 by a will be equal to 7 by 12 because a is greater than 1. In comparison, to get the value of a square plus 1 by a square, we would have to subtract 2 from 25 square by 12 square. The numerator would have been 25 square minus 2 into 144. None of these two terms would have a common factor with the denominators. And same is true for the other two factors in the numerator, 25 and 7. We ignore the denominators altogether because in all the four choices, the denominator values are same. This is where we'll apply our important speed technique using factors and multiples. Under the given circumstances, the three factors in the numerators should form the answer numerator when multiplied together. So we'll check the numerators of the choices for factors of 25 and 7. Among the four choices, the last two choices C and D have their numerators with 25 and 75 at the last two digits. Answer lies between these two. Now we'll check any one of these for the factor of 7. Choosing option C, we divide 59825 directly by 7. It doesn't have the factor of 7. So the answer must be option D, 58975 divided by 20736. If you actually calculate the products, you will see that this indeed is the answer. Let's write down the missing steps. A to the power 4 minus 1 by a to the power 4 is equal to a square plus 1 by a square multiplied by a plus 1 by a multiplied by a minus 1 by a. A plus 1 by a equal to 25 by 12. A minus 1 by a whole square equal to a plus 1 by a whole square minus 4 equal to 25 square by 12 square minus 4 equal to 49 by 144, which is 7 square by 12 square. As a is greater than 1, a minus 1 by a will be equal to 7 by 12. A plus 1 by a will have a factor of 25 in the numerator, and a minus 1 by a will have a factor of 7 in the numerator. As the numerator factors won't have a common factor with the denominators, we will test the numerators of the four choices for a factor of 25 first. Testing a number for a factor of 25 is very easy. The last two digits must be 00, 25, 50 or 75. Options C and D satisfy this condition. Answer will be one of these two. We'll test option C for a factor of 7 now. We find by direct division that the numerator 59825 is not divisible by 7. So the answer must be option D, 58975 divided by 20736. Answer is option D. We have cut short the calculations as far as possible by using the speed techniques, which depended on concepts of factors and multiples. Next problem. The input variable is a surd, and we must get rid of this surd by forming an expression in x. This is where we apply the rule of forming a sum of inverses on a surd variable free of surd. The rule is, if the surd variable has two terms and the difference of squares in the two terms is 1, then the sum of inverses of the surd variable will be free of surd. In our case, 3 square minus 2 root 2 whole square equal to 9 minus 8 equal to 1. So x plus 1 by x equal to 3 plus 2 root 2 plus 3 minus 2 root 2 after rationalization equal to 6 free of surd. Our first target is met. To transform the target expression in terms of x plus 1 by x, we divide the numerator by x cubed, getting 4 terms, x cubed plus x plus 1 by x plus 1 by x cubed. These 4 terms remind us of the 4 terms in the expansion of x plus 1 by x whole cube. The 4 terms in the expansion are x cubed plus 3x plus 3 by x plus 1 by x cubed. Our expression has the shortfall of 2 times x plus 1 by x. So we transform our expression to x plus 1 by x whole cube minus 2 times x plus 1 by x. 6 cube minus 12 equal to 204. Very easy and quick. Answer option C, 204. This problem needed application of a rule for formation of the sum of inverses of a surd variable free of surd, and then transformation of the target expression by identifying and using a special pattern. The solution was quick and all in mind. If you have liked this video, subscribe to our channel. Thanks for watching.